In this video, we are going to solve the problem Kruskal minimum spanning tree and really special subtree. So that is the name of the problem. Actually, this is a minimum spanning tree problem, and we are going to use a Kruskal algorithm to solve this. And we also have a minimum spanning tree with the Prim's algorithm. We will see that in the next video. Now let's see what is the problem objective is. Given an undirected weighted connected graph, find the really special subtree in it. The really special subtree is defined as a subgraph consisting of all the nodes in the graph, and there is only one exclusive path from a node to every other node. So we'll be having like, so if we have n nodes means we'll be having n minus 1 edges. So that is this condition. The subgraph of minimum overall weight among all the subgraphs, so it should contain only the minimum weight. It should not like having a maximum weight, because we are forming like minimum spanning tree, so the name represents the minimum overall weight. And finally, there should not be any cycles. As I already said, we will be creating only n minus 1 edges, so obviously there won't be any cycles in it. To create the really special subtree, always pick the edge with smallest weight. So this is like a greedy approach. We will be always picking the edges with the smallest weight and build our minimum spanning tree. Determine if it will create a cycle. So if you include that edge, it should not create a cycle. So that we have to check. If so, ignore that edge. If there are edges of equal weight available, choose the edge that minimizes the sum u plus v plus the corresponding weight, where u and v are the vertices and weight is the edge weight. If there is still a collision, choose any one of them. So this is the constraints and the steps we have to follow. Now finally, we will be printing the overall weight of the tree formed using the rules. And here for the example, we have 1 and 2, the weight is 2, 2 and 3, the weight is 3, 3 and 1, the weight is 5. So here we will just choose 1 and 2, that is having weight 2, and next choose 2 and 3, that is having weight 3. So the total weights are 5. 3 plus 2 is 5. We will be avoiding this edge because it will create a cycle, and we already created the minimum spanning tree by including the first 3 nodes. Now this is the overall steps, and here we have some example. This is the pictorial representation of the graph, and here they have mentioned 4 vertices and 6 edges with weights we have. So we have to follow the algorithm and return the total weight after building the minimum spanning tree. And here also we have one more input. So here for this example, we have the result. So this is the original graph, and this is the graph we are having without including the cycle. As you can see, this is a cycle, and this is a cycle, this is a cycle, 2 3 4 is a cycle. So like that, we have so many cycles. Now if you see this, we will be having a minimum overall weight and without any cycles. And here also see the whole graph is like a complete cycle, and they didn't like visualize the graph like this here. If you consider 1 and 2, 2 and 3, 1 and 2, 2 and 3, 3 and 4, and 4 and 5. So they are removing all these edges, and it will be having like a straight line graph 1 2 3 4 5. So after adding all the weights, you will be getting the results as 150. So that is the overall minimum weight for that minimum spanning tree. Okay, I think those are the examples. We will also trace some problem after building up our code. So I'm going to follow Kruskal algorithm. So we are going to add the nodes with minimum weight and form set. So you will be using rank and union in order to add it to the set, or create a separate set and combine it later. So like that we will be seeing. So first we have to form a graph like structure, because the variables we have given is like 3 different variables separately. I'll just create a graph for initialization. So I will go down, initialization, Now graph equals, I'm going to create an empty list. Now for u comma v comma weight in zip of g underscore from, this is the source of the node and this is the destination node g2, and we have the weight of that particular edge. So I'm going to add this into this graph so we can access it in a single go. So graph dot append, add this as a list. So u comma v comma w. Finally graph equals sorted off. As I already mentioned, we have to choose the weight which is the smallest. So we are just following a greedy approach. So here sort based on weight. Now I am going to sort the graph. Key equals, I'm just going to create a inline function lambda x of 2. So it will use the second index as the key. So the second index is the w, that is the weight. So it will just sort based on this key value. After sorting, we will be having the edges corresponding to the minimum weight. So it will be in order. So this is one initialization. Apart from that, we have to do few more. So parent equals v for v in range of g nodes plus 1. Again, this is a 1 based indexing. So it's not starting from 0, it's starting from 1. That's why I'm adding 1 here. And this is the parent. So if you are selecting a node, means you have to have a parent of that particular node. So for that, I'm just creating this list with the same value. So it will be just having let's say if it's 4, means it will be having 1 2 3 4. Each vertex will be pointing to each other, so it will be like isolated. And after this, I'm going to create rank equals 0 multiplies again g nodes of 1. Now rank is used when we are combining two sets. So if you already seen Kruskal algorithm, means maybe I'll just show you in the paint, it will be easy. So let's say if you are forming a set like 1 and 3, if this is already formed a set and you have a separate vertices formed, that is 2 and 4. So this is one set, this is another set with having different parents, and if you have a connection with 2 and 3, means we will be forming an union. So at that time, which one we have to choose it as a parent, so there will be some clash, right? So for that, we will be using that rank. So if you have more nodes here, means you will be choosing this as parent. Let's say if you have a 5 also, means the rank will be higher, so you will be assigning 2 as the parents. So this will be parent and this will be child. We will also track it later in order to understand clearly. So that is the purpose of rank. And after that, we will be having total weights. That is the final result we are going to return. So total weights equals 0. And apart from that, we have to initialize edges. So we are going to create only n-1 edges. So that's why. So it will be initialized to 0, and also I will create index I. So I equals, both will be initialized to 0 because we will be having this many number of edges. So we have to traverse all of that. Now we will go for the main logic. I'll just use a while loop. While edges less than g nodes minus 1. So this will satisfy the condition. Now I will get the graph. So u, v and w equals graph of I. So I'm just getting the minimum weight node. So here for this example, if you consider means it will consider 1 and 3. So that is the minimum overall weight. Here 3 is the weight. So I'm just taking it out. So apart from this list, you can also use DQ module. So you can just pop out and move on to the next. Like that also you can follow. So it doesn't matter. Now, if find of parent comma u not equals find of parent comma v. So what I am checking is check both nodes are not in the same set. So I'm just checking whether we already have that node. So let's say I already have that pick, right? So let's say you are already created 1 and 3 and these are all in the same subset. So again, if you have another weight having the same nodes means it will obviously point it to the same. So here parent of 1 is 1 and parent of 3 is 1. So find will give you the result as 1. We will create the find function now. So if both are equal means we will be just moving on to the next step, because obviously we don't have to add that edge. So this is the condition we are checking. Check both nodes are not in the same set. Now we will create the find function here. Def find. I will pass the parent and the node. So I can have it as node. Now if parent of node equals node, return node, or else again find of parent of node. So as I already told you in an example, so here initially if you have only single node, let's say if you have 1 and let's say if you have 3 separately, if you are use this find function means the parent is already initialized with the same number. So parent of 1 is 1 and parent of 3 is 3. So after that we will be performing some union operation. So then if you concatenate both these things means the parent of 3 will be changed to 1. So these two belong to a same set. So that's why we are just checking parent of node equal to node. So parent of 1 is 1, so it's same. So we'll be just returning the node as it is. If for 3 we are just checking whether it is the same. If it's not means we will be just going in a recursive manner and check until it is in the same subset. So currently this is in the same subset. Let's say if you have 2 and the parent is 2 and this is not in the same subset means we'll be forming the union as I said before. So this is the find operation. So returns the parent node of subset. Okay, that's done. Now we are just checking if both nodes are not in the same set. If that is not in the same set means we will forming an edge. So I will just increment it by 1. So we'll be adding the edge, right? So increment by 1, edges plus equals 1. And after that we will be having the union function. Maybe before that we will also add the weight. So total weights plus equals W. So that is the weight we are going to add. And after that combine both nodes into the same set. So for that I will be creating the function called union. So you will be passing both nodes, parent and rank. So now we have to create the union function. If both of them are same means we'll be just moving on to the next node. So for moving on to the next node I will just increment I by 1, and finally all this completes we will be just returning the total weights. Okay, this is like the whole main logic. We just have to combine, we just have to build this union function. So let's do that now. Combine both nodes in the same set or parent. Now def union of, again u comma v comma parent comma rank. First we are going to find the root of that parent. I will just have it as x root equals find of parent of u, and y root equals find of parent of v. So I'm just taking the root node or the parent node of the set and store it in these variables. Now after that we will check the rank. So if rank of x root is lesser than rank of y root, so we will just update the parent of x root equals y root, because that have a higher rank. So this y root will be the parent, that's why we are just assigning it. And the same goes for elif rank of x root is greater than rank of y root. Now parent of y root equals x root. Else, let's say if both of these ranks are same, means you can assign it to anyone. So when we have this condition is, initially if you consider only these nodes separately, like 1 and 3 separately, means initially both of these ranks are 0, so it is 0. So both are same, right? You can assign, or you can combine, or you can take any one of them as a parent, so it doesn't matter. Now here I'm going to say parent of y root equals x root, and rank of x root plus equals 1, because it is adding one more node to the set, right? That's why we are just incrementing the rank of x root here, and that is it. So if you do this operation, means the two nodes will be merged together. Now this is done, and that's pretty much the whole logic. So we are just sorted based on the weight and initialized a few important parameters, that is parent and rank. So this is how the Kruskal algorithm works, and we are just iterating through the edges which have minimum weights, and check whether both of these are separate nodes or it's in the same set. If both are separate subsets, means we'll be just adding that as an edge and adding the total weights and combining both nodes into a same set, and finally we will just return the total weights. And I already explained how this find and union works. Let me also show you an example. It's always better to see it with an example. Let's consider this problem itself. So I guess, how can we go? Pictorial will be better. I'll just clear this. Now initially every node will be separate, right? I'll be having 1, 3, 2, 4. I'll just mark this rounds. Sorry, 3 and 1. Okay, all of them are separate. So this will be 3. Now we will choose the minimum weight. So it is 1 and 3. So each parent is denoted by like this. I'll just take this as a parent. So 1 and 3 does not belongs to same parent, so we will be just forming an edge here with the total weight of 3. So I'm just marking the weight here, so we will add it later. So currently 3 is added, and this is one full subset, and after that we have 4, that is 3 to 2, 3 and 2, again you will be just finding, so this parent will be changed to 1 when you combine it. Now if you consider this is 1 and this is 2, so again we'll be forming an edge here, so this will be 4. I'll also mark the edges as like this. Now this will be 4. Again you can see the parent 1 has 2 nodes total, but this 2 has only 1 node. The rank will be higher here, so I'm just considering this as an parent. So this will be considered to 1. This will be converted, and after that we have 3 is done, 4 is done. We will take 5. We can take any one of them. Let's say 1 and 2. So 1 and 2 means both are having same parent, as you can see. So this is 1, this is 1. So it's like a cycle. So we don't have to go for this. So we will just leave this. And after that we have 3 and 4. So 3 and 4, if you consider the parent, so this is 1 and this is 4. It's different. So we will be combining this. What is the weight? That is 5. So plus 5, and you have to change the parent. So it has 3 nodes and this has 1 node. So obviously the rank will be higher for parent 1. So this also will be changed to 1. And we form the minimum spanning tree, but still we have 2 more edges, that is 4 and 1. So 4, 1, both are having same parent. We will need to ignore this edge or else it will form a cycle. And again here for 7 we have 2 and 4. 2 and 4 also having the same parent. Again we have to ignore it. So after that we don't have to form any more edges, and we don't have any more edges to see. So this is the minimum spanning tree we have got. So here you can see, and the final output is 12. And this is the graph we have got. So that's how the whole thing works, and I recommend you just do it or trace the problem for this example also to better understand. So you just trace the problem with the code. I'm just gone through the overview, like how the find works, and if they have both parents are same means we will skip. If they are not means we will combine. So like that I just gone through the overview. You just try to do it in the pen and paper way. It will be much more helpful to you. Let's run the code once. Showing wrong answer. Okay, I guess we have to print it here. It's not printing anything here. So I'll just print total weights. Now run this. Okay, I guess there is a problem in the main function. I'll just have this as a returned, and here I have to write fpt ptr dot write of string of result. So this is the variable. I think this is from Hackerrank problem. You don't have to do this. I didn't do this before. Let's run this now. I'm just writing it on that environment. Now it's working fine. Let's submit the code once. Yeah, we have solved that, all the test cases without any issues. And that's it, guys. This is the overall logic. If you have a simpler algorithm, well, obviously this is a Kruskal algorithm. We can't change it. We will solve the similar problem with the Prim's algorithm in the next video. Apart from that, if you like this video, hit the like button and subscribe the channel for more videos like this. Stay tuned for the next video.